So the next FRQ in our theorem rewind, I want to look at number 3 from 2013's AB. And again, crossover into the BC, but obviously these theorem type questions, it's always good to review these type of things. This time it revolved around a rate table from a contextual situation. You got hot water dripping from a coffee maker. It's filling a large cup. And it's from 0 to 6 minutes. So that's my closed interval. They're telling me that it's a differentiable function c, but you're going to see that actually, well, we'll get to that in a second. That would be the second derivative, right? Is measured in minutes. Oh, I take that back. This is minutes and ounces. So this is just kind of an F starting point. All right. T is measured in minutes, and then it looks like C of T is measured in ounces. And you know me, I always like to kind of put my units off to the side as a rate, because I always like to kind of wrap my head around what the derivatives units are, because I can then go any direction, and I always know what units I need to write down in my answer. All right, so we have use the data in the table to approximate C prime of 3.5. So the derivative at 3.5 for C. Show the computations that lead to your answer and indicate units of measure. So this again is just a slope of a secant line that we're going to do. You hear me say that a lot. I've been teaching for years. I know how to get this stuff into your brain. So in order to estimate C prime of 3.5, it's going to happen between 3 and 4. So if we calculate the slope of the secant line from 3 to 4, that'll be our best estimate, right, for the slope at 3.5. So I would just show them what I would do. I always notate properly. So I'm going to show them what I'm doing. And that would be over, what, 4 minus 3 is 1. Now remember, no calculator, there's decimals, and they do that to you sometimes. So that would be 12.8 minus 11.2 all over 1. Just be careful, that's what, 1.6 over 1 would be 1.6, but don't forget they wanted units. So again, change in Y would be your change in ounces, your change in X would be your minutes, so this would be ounces per minute. Now here's where the theorem came in. Is there a time t from 2 to 4 at which C prime of t is equal to 2? Justify your answer. Now I told you, intermediate value theorem would just be where C of t has to equal something on that interval. We are going derivative, right? We can even go to second derivative if we needed to based on what we had, and that would be mean value theorem. Mean value theorem is always state continuity, state differentiability. Find the slope of the secant line, right? That should equal what they're trying to have you figure out. And then that would have to be true according to the mean value theorem. All right, so let's break this down. Now remember, C is differentiable, right? So I would let them know that C is a continuous. Because remember, for the mean value theorem, in order for me to calculate the slope of the secant line, I have to have continuity on the closed interval from 2 to 4. So it's continuous, but I also need to show differentiability now. If I'm going to let the slope of the secant line equal to the slope of the tangent line, it has to be differentiable on the open interval from 2 to 4. Differentiable function. Always state that first. And I told you, do that for the IVT, the MVT, and for the extreme value theorem. But IVT, extreme value theorem, is just state the continuity. This one, you got to go one step further and talk differentiability. All right, the slope of the secant line, I always like to formalize this. I think you'll never forget how to do this if you practice this a certain way and understand it a certain way. So the slope of the secant line for C on the closed interval from 2 to 4 is, now remember, I would show them this. This would be C of 4 minus C of 2. All over 4 minus 2 is 2. C of 4 is 12.8. Now watch what happens here. Minus C of 2 is 8.8. So it kind of made itself nice and easy. All over 2. 4 over 2 is 2. But that should always line up on this mean value theorem. It should always line up. All right, now that we've shown that the secant line is that, we're just going to go straight into their words. There is a time t now remember, it's on the interior, right, of where I calculated the slope of my secant line, where it would equal the slope of the tangent line. So it's very important that you make sure you let them know that that t has to happen between 2 and 4. Get the endpoints out of there. At which c prime of t is equal to 2 by the mean value theorem. Done. All right, let's see what else and what other ancillary topics they had in here. Why not practice some more? Use a midpoint sum. So they want me to use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1 over 6 from 0 to 6 CT. Using correct units, explain what that means in the context of the problem. Average, right, average value, right? So this is going to be the average amount of coffee in the cup from 0 to 6 minutes. But we'll talk about that in a second. All right, let's do the most important part in terms of points on this question. Always just don't overwrite. Let them know that to get the integral, or 1 over 6 times the integral from 0 to 6 of c of t dt, using a midpoint Riemann sum, we'll approximate it, right? Now, I need to do some side work over here. So let's do some side work. So I need 3 subintervals or 3 rectangles to build this thing, right? I don't know how you did this, but you always calculate your d, or your width of each rectangle, right? Well, on the x-axis, from 0 to 6. So you go 6 minus 0, all divided by your n, your number of subintervals. So that means the width of each rectangle would be 2. Now you could build this rectangle by rectangle. Hopefully that you're schooled enough to know how to do the shortcut with this. All right. Now you should always find your x sub k's to determine what your heights of each of these rectangles are going to be. Now if I'm doing a midpoint, right, and I'm going from 0 to 6, so my interval goes from 0 to 2, but the midpoint would be halfway between 0 and 2 of my first subinterval, which would be at 1. So my first x sub k is 1. Once I plug that into c, that'll give me my height of my first rectangle. Then I go between 2 and 4, that would be 3, or you can just keep adding d, and then you would have 5 here, 1, 3, and 5. All right, now let's be careful. So the 1/6 has to come. I would put a bracket for my midpoint Riemann sum. Now remember, though, don't forget, it's always d times c of 1. I'm not even going to write that. C of 1 is 5.3. I'm just showing them how I'm getting it. Plus c of 3, which is 11.2. plus C of 5, which is 13.8. Now, again, you don't have a calculator, but I see what? This is 25. That would be 30.3. It should all work itself out, right? Just be careful. So this would be 30.3 times, oh, I take that back. I want to double that. I apologize. That would be 60.6. I almost forgot to double it. That's why you got to be careful, man. As you're rolling, sometimes you just forget to do stuff. Even I do that. So double the 30.3, all divided by 6. And notice how you can divide that out. That'd be 10.1. So that would be a good chunk of points there for you to actually get that. Now we got to explain that in the context of the situation. Again, try to use as much of their words as you can. So I would say 1 over 6 times the integral from 0 to 6 of c of t dt means, it says what's the meaning, so means the average amount, and you probably want to go up in here to get their words for that. So average value, we wouldn't want to say average value, do it to the context of the problem. So average amount of coffee in the cup for t greater than or equal to 0, less than or equal to 6 minutes is 10.1 ounces. And that should make sense. That's the average amount that you would have over those 6 minutes. Not bad. All right, last one. The amount of coffee in the cup is modeled. So they always love to give you a model. That's the whole point of calculus, right? Get a model from collecting data and then use your calculus to kind of figure some things out. All right, so they're giving me a model for what that table represented, but they're calling it B of t. Using this model, find the rate at which the amount of coffee in the cup is changing at t is equal to 5. So they want me to take a derivative. So they're testing on whether or not I know how to take a derivative of an exponential, right? Derivative 16, 0, I would have to take down, so 16 times, or a negative 16 times a negative 0.4. 4 times 16 is 64, so it would be 6.4, because it would have to be 40% of 16. Just kind of logic that out in your head, but it would be positive. E to the negative 0.4t, right? Derivative 16, 0, just be careful. B prime of 5 would equal what, 6.4. E, that would just be to the negative 2. It's always good to probably just flip that down as e squared. And I would probably answer this question. The rate, with a sentence, using their words, the rate at which the amount of coffee in the cup is changing when t equals 5 is 6.4, remember we don't have a calculator, all over e squared ounces per minute. So there's another one. Hopefully that helped you out, and keep the dream alive.